Hello and welcome to physics, a topic that talks about anything as small as light and as giant as galaxies. Today we're going to start in kinematics. Kinematics is the study of any object in motion. Today we're going to speak to scalars, vectors, time interval, distance, position, and displacement. In life, direction makes a difference. If I tell you I am 1 kilometer away from Nanning number 3 school, you do not know where I am. You know I am somewhere on this circle. If I want you to know precisely where I am, I need to tell you I am 1 kilometer south of Nanning number 3, and that tells you I am here. But we don't always need a direction. Some measurements do not need a direction, while others do. We divide those into scalars and vectors. Scalars are measurements or values that describe only the magnitude or size of a measurement. There is nothing special about the symbol in a scalar. Some examples of scalars are temperature and weight. On the other hand, vectors are measurements that describe both the magnitude and the direction. You can tell a vector by an arrow above the symbol. Some examples of vectors are when you give directions or when you describe your location. A temperature is a scalar because when you describe the temperature, you would say 25 degrees. You would not add a direction afterwards. You would not say it is 25 degrees up. That does not make sense. Weight is also a scalar. You do not need a direction. You do not say I weigh 80 kilograms up. That also does not make sense. However, some measurements require a direction. For example, if you tell somebody go 25 meters, then 10 meters, then 28 meters, you have just given terrible directions. When we talk about vectors and we have a direction, we need to have some conventions, something that all scientists can agree on. With directions, we need to be able to do math. You need to be able to determine west versus east, or left versus right. If we all use different methods, our calculations will not match. So as a convention, west and left will be considered to be negative, while east and right will be positive. Similarly, north and up will be positive, while south and down are negative. It is possible to change the positive and the negative to go the other way. But if you are doing so, you must say that you have changed the convention somewhere in your work. The first value we will look at is time, designated by the symbol t. Time simply describes when an event happens. In physics, we have two significant times that stand out from the rest. The first is the initial time, t sub I. This describes the time at the beginning of an event, or when does an event start. Our second time is the final time, t sub f. This is the time at the end of an event, or when does an event end. When you mention the time, you do not need a direction, so time as a measurement is a scalar. Time itself, as you will learn later, is relative. So what is more important than time is the time interval. The time interval tells you how long an event takes to happen. You find this by finding the difference between the initial time and the final time. Here, time interval is designated by delta t. This triangle symbol is called delta. Here, this stands for the change in something. For example, the time interval is also known as the change in time. We can find the change in something by taking how it is at the end minus how it was at the beginning. Or in other words, the change in time is equal to the final time minus the initial time. Or delta t is equal to tf minus ti. This delta is true for any symbol and any value, not only time. For example, if we have delta x, this is equal to the final x minus the initial x. Time interval does not need a direction, so it is a scalar. So now we know how to calculate the time interval. Try this problem. How long does it take the skateboarder to reach the sign from the fire hydrant? So in this problem, we want to find the delta t. We know delta t is equal to tf minus ti. The time when he is at the fire hydrant is his initial time, and when he passes the sign is his final time. So from this, we can conclude that tf is equal to 5, ti is equal to 2, and we can put those values into this equation, and we find the time interval is 3 seconds. This is very simple, but these are the steps you will follow for the majority of physics. Our next value is the position. Your position is the object's location from a reference point. It is very important to note that this is dependent on a reference point. The symbol for position is D with an arrow above. Some examples of a position would be to say the field is 100 meters to the west from here. Notice in this position, you require a reference point. If you say the field is 100 meters to the west of what? Nobody knows what you were talking about. Another example, Pizza Hut is 1 kilometer southeast from here. Again, you require a reference point from here. Notice also that this value requires a direction. You need to say 100 meters from the west, or 1 kilometer southeast. If you do not provide a direction, you have not given an accurate position. This has a measurement which requires a direction, so this is a vector. For example, what is the skateboarder's position at 5 seconds? At 5 seconds, the skateboarder has traveled 7 meters starting from the tree. So you can say the skateboarder is 7 meters east from the tree. However, you can change this reference point and have a different answer. Another answer is 5 meters east from the hydrant. There is one more answer. You could also say the skateboarder is at the sign, or 0 meters from the sign. All three of these answers are correct. They depend on different reference points. A different reference point gives you a different answer. So it is very important you mention where you are referring your measurement from. Our next value is the distance, designated by the symbol D. The distance is simply how far an object travels, or the length of distance traveled by an object. An example of distance is the odometer in your car. The odometer tells you how far you have traveled. In this example, the odometer is at the bottom of the speedometer. The number down here, 1,353 miles, tells you this car has traveled 1,353 miles. Notice in this example, there is no direction in the odometer, so distance is a scalar. Our next value is the displacement. The displacement is the distance and direction from one point to another. Another way of looking at the displacement is to say the change in your position. Simply put, the displacement is how far have you moved from the beginning. The symbol for displacement, as you can guess from change in position, is delta D, where delta is the change in and D with an arrow is your position. So simply, the displacement is your final position minus your initial position. Notice the difference between distance and displacement. If you move in a curved line, such as this dark blue line, your distance will be much greater than your displacement. Your distance is the total movement that you have done, shown in this purple dotted line. However, your displacement is only concerned with your final position and your initial position. It does not matter the path that you took to get to here. Notice displacement has an arrow above the symbol. This designates that you must have a direction in your answer. A direction means you have a vector. Try this question. What is the displacement of the skateboarder from 2 seconds to 5 seconds? Well, we know the displacement is found by the final position minus the initial position. Our final position here at 5 seconds is 7 meters. So we know df is 7. Our initial position from 2 seconds is 2 meters. So we know di is 2. Plugging these numbers into the equation, we find our distance is 7 meters east. Remember, position is a vector. Minus 2 meters east. This results in 5 meters east. So the displacement is 5 meters east. The skateboarder has moved 5 meters to the east. We also have 3 other questions to try. Consider this rollerblader. At 0 seconds, she is 9 meters east of the fire hydrant. At 10 seconds, she is 5 meters west of the fire hydrant. What is the distance she traveled? What is your time interval? And what is her displacement? The distance she traveled can be found simply by adding the total meters she moved. From the initial position to the fire hydrant, she moves 9 meters. From the fire hydrant to her final position, she moves 5 meters. Her total movement, therefore, is 9 plus 5, which gives us 14 meters. Her time interval is simply her final time minus her initial time. Her final time is 10 seconds. Her initial time is 0 seconds, so her time interval is 10 seconds. Her displacement is simply her final position minus her initial position. Here we see a slight difference in the problem. At the end, we can find her at 5 meters to the west of the fire hydrant. At the beginning, we find her 9 meters to the east of the fire hydrant. Here we have two different directions. This can be resolved by looking at our direction convention. Here we know east is positive and west is negative. So instead of placing 5 meters west, we may write minus 5 meters to the east, minus 9 meters to the east. Now these two values match, we can place them together. Minus 5 minus 9 is minus 14 meters east. This can also be written as 14 meters to the west. Finally, try this question. The skateboarder moves from the fire hydrant to the sign and then back to the tree. What is his distance he travels? And what is his total displacement? His distance can be broken down into two parts. From the fire hydrant to the sign, he moves 5 meters. From the sign to the tree, he moves 7 meters. So our total distance is 12 meters. Our displacement is much easier. Remember, the displacement is your final position minus your initial position. Our final position is 0 meters from the tree. Our initial position is 2 meters from the tree at the fire hydrant. So his total displacement must be minus 2 meters east. Another way to think of this, he travels 5 meters to the east, and then he travels 7 meters to the west. We cannot add east and west, so we must change this to, we cannot add east and west, so we must change this to minus 7 meters east. Notice 5 minus 7 gives us minus 2 meters east, the same as what we had before. This is everything you need to know about scalars and vectors, specifically time, distance, and displacement. Thank you for watching.